Welcome to week one of working mathematically in the early years of schooling. I'm Robin Jorgensen and my background is in mathematics education. And so what we want to do in today's session is to get you to think differently about how children might be learning mathematics. There's been a quantum shift in the way that you may have experienced mathematics in schools to the way that we're wanting people to be teaching mathematics. So there's a significant shift. This session, hopefully, we'll do a little bit of recall about what it was like for when you went to school and your memories of mathematics, and what we're hoping that you will leave this course with in terms of your own teaching of mathematics. There are four key areas that we'd like to explore in today's session. One of them is problem solving. The others are ways of working mathematically. We want you to really think about how children can communicate mathematically, but also how they can reason or think mathematically, and also making connections within mathematics and beyond mathematics. So let's go back to when you were at school and think about what your experiences were like. Do you remember your teacher perhaps putting a lot of what we'd call sums on the board and you had to work through them? Perhaps they used an overhead projector and put a lot of sums up that you had to work through. Then you would, in all likelihood, have been given formulas. So if you were exploring the area or volume, for example, you were given a formula, and then you had to put the numbers in and calculate them out. Often you had no idea what the real answer was, but if you followed the step-by-step procedure, in many cases you got the answer right, but often you didn't understand what you were doing. You might also have recollections of the teacher telling you what to do. The teacher was in control of the lesson the whole time. The teacher often sat at the front of the lesson, gave instructions, then you would sit down and do it. There was also often right and wrong answers. So if the answer were 36, then if you got 36, you got a big red tick. If you didn't get 36, you got a big red cross. So when you think about what your teaching or your experiences of mathematics was, I'm sure you'd be thinking that there was a lot of working on your own. The classrooms were very, very quiet. There was very little talk, very little interaction amongst the students. It was very much solitary work, and often it was associated with a lot of pencil and paper work. What we want to do in this course, though, is really challenge that way of teaching, because what that fostered was the notion that we do mathematics. So you do mathematics in a particular way by putting numbers into equations and hoping you get them right. And what we're wanting to do now is to radically change that. So the emphasis now is on getting the children to understand mathematics, understand what they're doing. We want them to think mathematically, and we want them to work mathematically. So let's have a look at those four main areas. The first one is problem solving. And problem solving has gone through a number of iterations in terms of how it's organised in the curriculum. It has been sitting out in previous drafts of curriculum documents, whether they've been state or the new document, the new national document, as an area that stands out on its own. There's debate about whether it should be standing as an area on its own or whether it is something that is done across all strands of mathematics. Current thinking is that it's something that's embedded across all of our mathematics. The danger of when that happens is it doesn't get done. So you will see in the new curriculum there are ways of working mathematically that are very important. What we then tend to do now is, rather than the teacher standing at the front of the class and giving instructions about do step 1, step 2, step 3, what we're really looking for is a problem solving approach. So you do not teach concepts in the same way that you may have been taught them, but we do that through a problem solving approach. So the conceptual understandings evolve from that teaching process. One of the big challenges for you as a teacher, though, is because often teachers need to feel as if they're in control, is there's always a temptation to help students so that they can get answers quickly. But this has to be avoided when we're using a problem-solving approach, because what we want the children to have is some challenges in their mathematics learning. We know that that's good for the mind. It makes them think mathematically. It helps children gain confidence and the skills and dispositions that they need to have towards mathematics. So when we're thinking about problem solving in the early years, here's a number of ideas that you can use. So In the early years, it's a very different approach, of course, from the middle years and the upper years when the students have got much more complex understandings of mathematics. So, for example, a really good activity that you can do with young children is if they're doing water play, rather than getting them just to, as they pour the cups of water into the jug and getting them to do counting activities, before they start the counting activities, ask them to guess or to estimate how many cups of water do they actually think might fit into that jug. And then what they're doing is developing skills about counting, estimating, but also volume, visualising how many cups of water may fit into that. Then once they've had their estimate, then let them go through the process and count how many cups fit into that. What you will hear a lot about in schools are two main approaches with problem solving. You'll hear about Polya and his problem solving approach, and Polya argued that for problem solving, before we start, the children actually have to understand what the problem is, and after they've worked out the problem, then they need to devise a plan of how they will do that. Then they need to carry out the plan, and then they need to look back. They need to check if that's correct. So if we go back to the example of how many cups of water do you think would fit into the jug, then they have to understand what the question's asking. It's asking them to guess. It's not asking them to pour the water and then count. First of all, we're asking them to have a guess, and we're looking for reasonableness of guessing. Then they have to devise a plan, and in this case it's simple. They'd be just pouring the cups of water into the jug. But you may need to prompt the children around those strategies. Then they carry out the plan, as in they then pour the water in, and then they look back and they evaluate their response. So if they've guessed that they might be 16 cups of water and there are only 4, then they've got to start thinking, and that metacognitive process is very important in problem solving. It's getting them to evaluate the reasonableness of their answer, where they may have gone wrong, and things like that. So those 4 steps are very important. We also talk a lot about problem solving strategies, and here's a list of what they are. You'll often see in classrooms, particularly as you move towards the later end of the early years, you might see some of these things happening. So I don't want to go through all of those, but basically we're looking for patterns so the students might see that. Sometimes they can't solve the problem, so instead of using big numbers, we might use little numbers so they can work out the strategies and so on. But this list of problem solving strategies is very common in maths classrooms. We also know that whilst those 2 approaches are dominant, we need to have a more holistic sense of what is problem solving. So when we look at problem solving in the early years, you need to, as a teacher, devise good problems for the students to work on. And through that problem solving approach, what we're really looking for is the students to develop dispositions towards problem solving, but also being self-reliant so they can trust themselves. We also need to be building resilience, because what we do know is that many students, when they're given problem solving, or even when they're given mathematics, they give up far too easily. So what we're really looking for is building resilience in our students. We're also looking to build enjoyment, empowerment, and a fascination with mathematics, so that they have and they develop and you nurture a love of mathematics in our young children. We also need to develop, as teachers, an atmosphere to encourage learning about mathematics, learning and applying those mathematical ideas and thinking towards solving problems. So we've talked a bit about problem solving, but what you will also see is there's an area called problem posing, which is where students actually pose the problems themselves and then work out strategies on how they would do that. The second area that we need to look at is communicating mathematically. If you think back to your own experiences, you sat down, you worked in a solitary environment, and you never did very much communicating. But mathematics is a social activity, so the students need to be encouraged to talk mathematics. They need to talk with each other, they need to negotiate meaning, they need to negotiate strategies and so forth, and in that process they are starting to talk the language of mathematics. Many words in mathematics are quite unique to our field, and many of the words that we use in mathematics are common across our fields, and we'll talk about that later on. They also need to develop the social skills for communicating with their peers. So you can't just expect to put children in groups and expect them to work. Your job is also to get their social skills to work with each other. They also need to develop through that process the language of mathematics and all the unique words that we have in mathematics, as well as the concepts. So communicating mathematically involves talking, listening, writing and reading mathematics. What is unique about mathematics, it is also very symbolic. So unlike any of the other curriculum areas, maths has its own symbols. So you'll be familiar with the numerals, but also if you think about the operation signs, plus, minus, divide, multiply, even the notion of equivalence, the little two parallel lines which I've often referred to as equals. This is very symbolic and they have very, very unique meanings for our contexts. And so kids need to understand the symbolic language of mathematics as well. So when we think about communicating mathematically, there are three main forms of representation in mathematics. First, we have this concrete representation. So we often start with children with counters and things like that. So they start to see that this collection of items here is the concept of three, or the threeness, or what we call the cardinality. Then they need to have the language, and this can be the oral language, the language they hear, or the language that is common across our other words, the written language. And they also need to know the symbolic language. Your job as a teacher is to reinforce these three forms of representation in mathematics, so that they can communicate mathematically across those three forms of representation. So some strategies that you can use are getting the kids to sit back to back and create a drawing of a house, sitting across the cardboard screen where they have to give directions to each other about how to build towers and so on. That's one part of it, but the other part is critical as well, is when you remove the screen, get the kids to check how similar the constructions are, and then they can start to see how important their language is in terms of their communication. And similarly, making maps of classrooms is another good strategy you can use. The third part is about reasoning mathematically. And so when we're talking about reasoning, what we want children to do is draw logical and reasonable conclusions about mathematics. We're asking them to explain their thinking processes. We're asking them to justify the solutions they've arrived at, but also how they've arrived at those solutions. So it's really getting them to communicate, but communicate about their reasoning. And there's very, very different ways that they can do that. So you can see here, there's the oral language, but also they need to draw on patterns and relationships between concepts that they see. And what we're really looking for is that they're demonstrating their understanding of mathematics and how it makes sense to them. Reasoning mathematically is also strongly embedded in the whole problem-solving approach, where not only are they doing problem-solving, but as you can see, they're reasoning and they're communicating mathematically. All of these things are now starting to tie together. What is really important is that you create an ethos in your classroom where the children feel safe to explain their reasoning. They're not going to feel intimidated about what they're doing. So here's a number of ideas that you can get the students to do in terms of reasoning mathematics. So you can look at these after, but what numbers add up to 10? And how can they do that? Can they see any patterns in what we often call the rainbow numbers, 1 and 9, 2 and 8, 3 and 7, 4 and 6 and so on. What we're also looking for is in that process, while they're explaining their thinking, looking for patterns, your job is also to promote and provoke conversation and reasoning. So you could pose questions such as, are 4 and 6 the same as 6 and 4? And similarly, you can do the same with shape. And finally, we need to be in mathematics is about making connections. Mathematical concepts don't exist on their own, so making connections within mathematics is very important. For example, is addition the same as multiplication? We would know, because we're much older, that they're probably slightly different. But on the other hand, if students are struggling with 3 times 4, What's the problem with the multiplication? If they understand that 3 times 4 is 3 groups of 4 or 4 groups of 3, then repeated addition, as in 4 plus 4 plus 4, may be as effective as the multiplication. So the connections between, in this case, addition and multiplication are very important. Similarly, making connections to other areas of the curriculum is also important so that maths doesn't sit out on its own. Maths is actually an informing discipline that we use nearly in we do use in every other curriculum area. And once you enter schools, what you're going to see a lot of is what we call numeracy across the curriculum. So where is mathematics or numeracy in other areas of the curriculum? We also need to make connections beyond the worlds of schools and preschools so that students can see that maths is everywhere. It's part of their lives. It's part of their everyday living. And that's really important as well. So if finally what we think I would like you to do is in groups or with other people is if you look at this picture here, this is an example of a sorting activity which we do a lot in the early years. So in this case, what we often do is we'll ask the students to sort those fruits. Now in this, what we often think is that sorting means we put the bananas together, the pears together, the grapes together, and so on. Or some kids might sort them by colour. So the green apples and the green bananas are going together, but they're sorting in particular ways that make sense. This is an example I've come across many, many times where you can see here there's 3 pairings of fruit. Now, they don't look like they've been grouped by any category. But in actual fact, when you ask the students, what they've done is they've created groups that are different. None of the groups are the same. So your task is always to identify what the child's been thinking, so they're getting them to communicate and reason mathematically. Whilst that might be correct, it may not be desirable. So what you've got to do as a teacher is now think about how you might get that child to sort those fruits in a way that is more socially legitimate in the maths classroom. But also you need to think about how you can get the child to communicate and reason mathematically about his or her thinking and sorting processes. So have a think about how you might do that, and let's follow that up on the discussion board, or if you've got somebody close by, you may be able to talk that through with them. Okay, so we've finished our first session. Hopefully there's some challenges in there to get you to think differently about how we might be teaching mathematics, particularly in the early years, that is different from your own experiences of mathematics.